Okay, so we are live. Hello, everyone. This is Sachin Soni. Most of you must be knowing me through my YouTube channel with that logo on my back. I'm a YouTuber. I used to run a YouTube channel called as Techie SMS, where I used to put up the content like electronic projects, IoT projects, some embedded projects, and also review some new and cool hardware and software-based things coming out in the market to let my audience know what's currently running in the market. Also, I used to cover some wireless technologies as well. And talking about the wireless technologies, I'm introducing this month's episode. So, first of all, thank you so much, Hackster, for letting me host this show. I don't remember if I ever hosted any show before, but anyways, it's kind of a new feeling. But yeah, thank you so much, Hackster, for giving me this opportunity, this platform. So, this is an Impact Spotlight, a monthly series run by Hackster.io team, and every month we have a different theme, and this month's theme is connectivity. So what actually Impact Spotlight is? Well, in Impact Spotlight, what we people do, so I'm considering me as a Hackster people, and I'm a Hackster pro as well. So yeah, in Impact Spotlight, what we people do is we used to find out the community people around Hackster who has done some amazing work. Okay, so as every month we have different themes. So as of now, this month theme was connectivity. So we kind of try to find out some amazing, cool projects around the wireless connectivity theme, and we just let the community member. We just invite those people to come onto this platform, talk about their project, share the story, why they made, how they started, what challenges they faced, and how the final project looks like. And in the end, they can also share the links about how they made it, so that people watching the stream, people watching the video, can actually make the project by themselves as well. Okay, so that's what all Impact Spotlight is about. And today's episode is about wireless connectivity. And let me tell you, we're going to have a bunch of projects from community members, definitely showcasing their projects under the wireless like connectivity theme. But the great part, what I decided, hey, come on, I'm the host. I can do anything what I want. That's what Hackster people told me. So what I come up with is I thought the people joining the live stream, let us discuss about what wireless technology, or rather, what new wireless technology they have recently heard of. So be interactive on this chat. Try to comment about which new wireless technology you are aware about, and let everyone know that this thing exists. And in between the videos, I will let you know a couple of new and interesting wireless technologies which I came across that made me feel, wow, this is so amazing. So this is all about this session. I'll put up one by one video from community member. In between, we'll discuss some wireless technology. Does it sound fun? If it is yes, just type fun in the chat. Let me just see how many people are having fun with me. I can see the chat right now. It's over. It's over LinkedIn and YouTube. Can anyone type fun in the chat that I can see here? Later, we can start off with the first community member. Okay. Okay. So Aman is having fun. Okay, I don't. Okay, Maker Brain. Oh, Mukesh is also here. Fun. Everyone is having fun. Chill session with me. So we are good to go, I think. So the first community member is Eric. So Eric will be joining us through the video. He will be presenting his project, which is about payment gateway lockbox over LTE. And let's have a look over that project. Let's discuss more about it later. Can we have the project from Eric?
Hey everyone, my name's Eric. I'm an engineer focused on hardware and software for connected devices. I've been exploring LTE connected projects recently, and today I'm going to talk about the honey cabinet that I built. I'll give a little context. So recently a family friend got into beekeeping and as a result had a bunch of leftover honey. So we're kind of brainstorming what to do with the leftover honey and decided on kind of a little free library style cabinet where the cabinet would be full of jars of honey. Users could scan a QR code, they can make a payment for a jar of honey, and once the payment confirms, the door can unlock and maybe install this in in their front yard or like on a neighborhood corner or something like that. So the hope would be that you'd have totally hands-off selling. You wouldn't have to keep cash out in the open. You wouldn't have to rely on the honor system for people to just choose what they purchased or provide cash or anything like that. So let's talk about this enclosure that we designed. I opted to design my own cabinet rather than trying to purchase something off the shelf to try to keep the costs as low as possible. I really wanted to be able to have everything cut out of a single 2 foot by 4 foot sheet of plywood. In this case, it's 1/2 inch. And I modeled everything in CAD before making any cuts because I'm very much a computer person and less so a woodworker. And here's kind of what I ended up with. We've got the door here with a cutout for clear plexiglass or some kind of see-through material so you can see what's in the cabinet itself. We've got a slanted roof to shed any weather or rain or anything like that. There's a shackle and lock system, which is going to control access to the enclosure. And then I've got some 3D printed, intended to be 3D printed drill guides to make sure everything lines up correctly. So here's how it turned out. So next, let's talk about how we're going to manage the inventory. One of the design goals was the ability to see how many units are left in the cabinet remotely. So I explored a couple of different ways to do this, and between cameras or some switch mechanism or something like that. And I settled on load cells, and the idea being you would calibrate the system based on the weight of one unit, and the firmware could calculate how many units are left in the enclosure, and you can get that information remotely. You could prevent someone from paying for a unit that might not be there if the inventory is completely gone. And what I ended up using these individual strain gauges and essentially making kind of like a smart shelf. All right, now let's talk electronics, which I expect is why everyone's here listening to this video. For electronics, we need to answer 2 questions. The first being power and the second being connectivity, how the device is going to connect to the internet. After some deliberation, I ended up choosing to go forward with the particle ecosystem. The particle ecosystem allows for super easy development, and it's got solutions for everything that I need for this project. Within the particle ecosystem, I opted to use the MSOM, which stands for the Multi-Radio System on Module that Particle offers. What's nice about this, and you can see it on the upper right-hand corner here, is that it offers Wi-Fi and cellular out of the box without having to deal with SIM cards or getting too crazy with radio layout. Particle also offers a power module that allows an easy solution to some of the unique power constraints that the MSOM requires. For load cell measurement, I went with the NAU 7802 ADC, which is an I2C analog to digital converter that makes measuring the weight of the system pretty easy with well-supported software. And then I have some MOSFETs that switch the 12-volt power out to the 12-volt solenoid that we're using to lock the entire enclosure. Let's talk about the firmware for the system now. The firmware is relatively straightforward. Really, all we need to do is make sure we can unlock the device remotely. This is made really easy with Particle's cloud functions. I've also exposed another couple of operations like the tear, the calibrate, and the refresh commands. And I've got a ledger set up, which is a new Particle feature, which allows you from any sort of web application to query the current state of the device and get information like our temperature or our inventory. From my application code, I don't have to subscribe to events or make sure I'm not missing any messages. It makes it really nice and easy. And so really the main event loop is quite straightforward. I'm just grabbing information from the sensors, I'm uploading them to the ledger instance, and I'm really just waiting for if we should send an unlock signal to our solenoids. Let's talk payments now. I've patched together a number of different services to manage the payments for the system. I'm using Stripe to process and confirm the payment information from the user. It's Stripe hosted payment links. Once a payment gets confirmed, it calls a webhook to a serverless function that I've configured, hosted in AWS Lambda. That serverless function is responsible for calling the Particle API, which then makes a request to the Particle cloud function that I defined in my firmware. I can do some fun things with Particle as well, like the ledger instance that I mentioned before. In my AWS Lambda, I can check to make sure that the inventory that I've measured in my firmware still has some remaining jars of honey, and I can prevent any sort of payment from going through if there's no inventory left for the user to grab. And that's kind of it. That's all the pieces put together. I've got a video showing a payment being processed here. So now I'm filling out the payment information. This can be done on a computer or your phone as you're walking by. And we'll give it a second to confirm here, and Stripe process the payment, and you can see the door opened.
Wonderful. So that was a project from Eric, and what? Actually wanted to make the similar project for me. So I also run a e-commerce store along with my YouTube channel. So on my e-commerce platform, I used to sell the electronic components and boards and sensors and all those stuff that you guys play with them on your desk. So I used to sell them on my website, techasms.com. So I was thinking of to make a kind of a, what you can say, a vending machine for some, what you can say, the most selling projects. So I can take that vending machine to any of the events as well, so people can scan the QR code, pay, and get this stuff. Just kind of fun DIY project. As like this I remind, like, it reminds me of the project which is pending by watching this video. So this was a great project, and I definitely want to make that as well. Let's see, in future I'll definitely make it. But that is a really great project from Eric. And now it's time to talk about some new wireless technology. Just 1 minute, short but new. And if you feel wow about that technology, I want wow in the chat section. Okay, some people may know it, some people may not, but yeah, this is the Apple AirTag. And you know what? I just love the technology used behind this. This tiny little coin-sized device doesn't have built-in GPS, but still you can locate this tag at any corner of the world. That is the beautiful. That is the beauty about the technology. Without GPS, how can we get the location? Well, how does it works? It has two technologies. One is the ultra wideband. One is the BLE. Using the ultra wideband technology, you can track this kind of tracker within the room itself. Like, is it under the table? Is it behind the television? Anywhere you can search for it. And to locate it around the world, Apple introduced a very beautiful way. So what Apple does is, this AirTag has a Bluetooth technology, so it's kind of broadcasting its Bluetooth identity. You can say a BLE beacon if you have heard about it. So if there is some Apple product nearby, just like an iPhone, so it communicate with the iPhone, any of the iPhone, not my iPhone, any of the random iPhone, it communicate with it. It get the location of the iPhone. It's sent to the cloud of the Apple, and that's how Apple recognize that this tag is near to this iPhone, means it's near to this location. Isn't this a wow technology? This is a wireless wow technology, which I loved about. And this all works in the Apple, mesh network, you can say, between the Apple devices. Many people said wow in the chat section. So thank you so much for this wow. And I felt wow when I heard for the first time. We have more wow technologies coming up. So before that, let's hear from another person, another great community member. Well, it's a duo. So we have Vishal and Shlok, who will be presenting their project called as LoRa Messenger. So can we have the video from Vishal and Shlok?
Without internet or a SIM card. Hey everyone, thanks for joining. Today I am sharing a fun project called Lola Messenger. Basically, it lets you text your friend without internet or a SIM card. Sounds interesting? So here's how idea started. A while back, I was on a hiking trip with my friends. We lost network connection completely. I was about 2 meals ahead carrying all the medicines while my friends had all the food supplies. We had decided to meet at certain checkpoints, but honestly, if we missed each other, we were lost. And in that moment, one thought hit me: why do telecom services fail in such places? The answer is simple: at high altitudes, there are hardly any population. Some areas are unexplored, so there is no reason for telecom companies to set up towers there. So I thought, why don't we take responsibility to networkify the area we are hiking on? When I got back to my workshop, we started brainstorming that when the idea clicked, why not use long range communication modules? LoRa, for example, even holds a world record of nearly 300 kilometers in open areas. And the cool thing is, higher altitude means the even greater signal range. After exploring the options, the SX1278 long range module stood out. Cheap, reliable, and perfect for this project. So um, here's what we build: a small device that connects to your phone via Bluetooth. The phone sends you text through a serial app, which convert it into a string. That string goes to LoRa module, which shoots it out over long range around 8 kilometers. Another device receives it, passes the string back to Bluetooth, and then to other person's phone. Boom, message delivered without Wi-Fi or without any SIM card. Here's illustration diagram, and yeah, I know it look kind of a crazy, but it works. Here you can see the circuit diagram. The LoRa SX1278 module needs to be connected to a microcontroller. In my case, I am using Arduino Nano. It supports SPI communication, and since LoRa SX1278 works on SPI, it's connected directly to the SPI pins. Next, I've added a 3.3 voltage regulator, which is very crucial for most of the LoRa modules that runs on 3.3 voltage. You'll also notice a small switch connected to RX and TX pins of the Bluetooth module. This is a good practice because when you flash upload code to Arduino, the RX and TX pins are already in use. If the Bluetooth is still connected, the flashing process can fail. With the switch, I can disconnect it easily when uploading code. I also added a buzzer which acts as a notification system. It buzzers to remind you to turn on Bluetooth and open the Bluetooth serial app when someone sends you a message. Finally, LoRa has a really cool feature. It can work in a mesh network. That means you can connect multiple devices together. The more devices you add, the greater the overall range you can cover. So instead of being limited to one, you can extend communication across the chain of devices.
We have two Arduino programs here, one for my device, which is user 1, and other from my friend's device, that is user 2. Both codes are almost the same, with just the device addresses swapped so they know who they are talking to. First, we include the LoRa and SPI libraries, which allow the boards to send and receive messages wirelessly over their required frequency band, that is 433 MHz. Each device is assigned a unique address. For example, my device has set up 0xPB as my address while my friend's device has 0xFF. This way, the messages don't get mixed up. In the setup function, we initialize the serial monitor and LoRa module. If LoRa fails to start, the device just stops. We also set up a buzzer pin as an output. The main loop does two things. The first one, it checks if there is any serial input. That means if I type something, it gets sent to the other device using the send message function. The second one is it constantly listens for incoming LoRa packets using the on receive function. Inside send message, we build a packet with details like destination, sender, message ID, and the actual message string. This makes communication more structured and easy to understand. When a packet arrives, on receive function extracts the data. It checks who is it for, who sent it, and the message content. If the message contains a special code like 69, the buzzer is activated 3 times. Otherwise, it just prints the message to the serial monitor. Finally, we use a small helper function, getValue, to split the message and read specific parts of it. So in short, this project allows two LoRa devices to send and receive messages and even allows for broadcast in some scenarios, along with triggering actions like buzzing an alarm when a special code is received. It's a simple yet powerful way to build communication without internet or SIM cards.
So yeah, again a very great project of like mixing two different technologies, LoRa and Bluetooth, and what a great problem statement. Like LoRa actually feels really useful at that position where there is no wireless connectivity available. But this project do remind me of some products whose video I made like a couple of years back. I don't remember, but yeah, this is the watch, and this is kind of a walkie-talkie kind of thing. Both works on the same thing, LoRa plus Bluetooth. And this company, this is from the Liligo. Okay, I'm not sure if I can say the name or not, but yeah, I did. I'm so sorry. But anyways, this products, what they do is they have the Bluetooth and the LoRa in it, so they communicate with our phone, right? And they can communicate via LoRa, like device to device. So what happens is this is working on a Mestastic technology. You can see. So in Mestastic, you have a ready-made mobile application, just like a WhatsApp. So you can open up that WhatsApp kind of application, just type any message. That message will from the phone from the phone, the message will be transferred to this watch via Bluetooth, and this watch will transfer the message to another device via LoRa in between kilometers, and then again this device will communicate with your phone via Bluetooth, and you can get the WhatsApp message, kind of WhatsApp message, not exactly WhatsApp, but yeah, that's how the Mestastic technology works. That is really really amazing, and this project was about that Mestastic technology only. Okay, but anyways, let me tell you one more wow technology. So Mukesh already said wow about this, but yeah, I do have one more wow thing. So what Apple did was really amazing. Where it is? Oh yeah. So what Apple did is really amazing. But recently, when I was working on one new module, I found that Amazon came up with a similar thing. And if you find it new and interesting, just type wow in the chat. Okay. So what Amazon did is Amazon said, hey, if Apple can do this, why not us? So Amazon came up with a new technology called as Amazon Sidewalk. So what Amazon Sidewalk is all about? Well, Amazon Sidewalk is again works on the same fundamental on which this ad tech works. So Amazon got multiple devices, just like I have my Amazon Alexa sitting behind me. Okay, so my Alexa can talk to my Wi-Fi router, and my Wi-Fi router is at my studio. It knows my location. So my Alexa also knows my location. So what Amazon did is, just like Alexa, Amazon have a bunch of other devices as well, just like camera, just like a Fire Stick, or and wireless routers as well. I'm not sure, but they do have a couple of those products. So what they did is they introduced a technology called as Amazon Sidewalk, which works on Bluetooth and LoRa. Okay, so via Bluetooth, so they will be introducing this kind of tracker kind of thing, which can communicate via Bluetooth to the Alexa, and if they are far away, they can talk via LoRa. But basically, the concept is, with the help of Amazon devices network, you can find anything like kind of personal tracking, asset tracking. You can build those kind of, or they are going to build those kind of products under Amazon product network. Same thing which Apple did. Are you aware about it before? If not, just like wow, Amazon Sidewalk. That's the technology. Anyways, so we have other technologies as well which I need to discuss, which made me feel wow, so I'll soon discuss it. But before that, let me just go ahead and talk about another community member who did a great thing with the showerboard. So his name is Pradeep has built a 3D printed, okay, sorry, his project name is 3D printed mini time lapse camera with the help of Xiaomi SP32S3 Sense. So yeah, let's play the video from Pradeep and let's see how his project looks and how he made it.
Hello everyone and welcome you to this Hackster Impact Spotlights. So in today I'm going to present my project, which is 3D printed mini time-lapse camera, and my name is Pradeep. So first let's talk about myself. So as I mentioned, my name is Pradeep S. I have been working as semi-connected test engineer for over 5 years, and apart from my professional work, I'm actually working in embedded systems and IoT development for like the same amount of 5 years, and I'm building modular projects and some other die products, die things, and sensors, controllers. So I'm working on those things like as my hobby, and also I am building like projects and I'm making tutorials on Hackster.io as well as some other platforms. So this is my short about me. Then let's start about my project. Okay, so my project, which is like the 3D printed mini time-lapse camera. So the motivation behind this one is actually I was building many die things and I want to record what I'm doing. So the thing is, I want to make like a time-lapse video for all the builds what I'm doing. But the issue is, I have the camera and lot of things, but the issue is everything is too bulky and I can't easy to carry, and I want the things which is like very minimal and very easy to use. So what I build is I build a mini camera which is using some the ESP32 controllers and some 3D parts. So I build a mini time-lapse camera which is easy to use and easy to carry, very low power consumption, and which is working very easily. So this is my motivation to begin my project. And the bill of material which I used is, as I mentioned, I have used the Zio ESP32S3 Sense, which is controller from Seed Studio, and the best part is it has the onboard camera as well as onboard SD card slot, so I can easily plug my SD cards and I can record the pictures and I can store it them. And for the enclosure part, I can't directly use the controller, right? So I need some enclosures. So for that, I have used 3D printed enclosures, which I fabricated from JustWave, which is one of the 3D printing company. So I just ordered the 3D model from there. And for the power supply, I have used USB power supplies, but if you want, you can use battery powers also is possible. And the tripod and stands are optional based on your need. So now let's start the construction of my project. So the step one is the motivation. So as I already mentioned, my motivation is to make a time-lapse camera, so which I can use it any situations what I want. So but the thing is, it should not be like a big bulky one. So I need a small and low power consumption and a easy to mount wherever I want. So that's the main thing objective of this one. So for that, I have selected the component very carefully. So the first one is I have used this Zio USB32 S3 from Seed Studio, and SD card for storing the files, and I have used the 3D printed enclosure from Just Wave service. So this is that process what I did. So I just ordered the PCB, that 3D elements, and I had just connected the camera as well as the controller, and this is the final part. So you can just combine everything together and it's just good to go. So for the flashing the firmware, I have used Arduino Sketch. So that sketch can actually take multiple images in a particular time interval, and it will store all the images into the SD card with different timestamper in a file name, so that I can easily sort the files. Okay. So then I have added some retry logic also. For example, sometimes that file may be corrupted when writing the files. So I just added some retry logics to verify whether the files are exactly righted or not. So then this is my final assembly. So I just mounted all the elements, and this is how the final thing look like. And I just captured some multiple images. So this is how it captured it. You can see like all images are like similar one, but it is not the same images. Everything is captured from different time frames. So once I capture all the images, next thing is I need to combine and make a video. So for that part, I have used Python script. So in the Python script, I use OpenCV library. So that library can actually take all the images and it will convert into the video. So I just define my what is my FPS for the video, and I just get the script, and the script will give me the video. So this is the final video which I take from the Zio ESP32 S3. It sends like I'm not sure how long I take this video. So this is actually this is not a video. This is the image which is captured from multiple time interval, and the Python actually created this video. So this is actually created from Zio ESP32 S3 sense. So at the final step, the next phase, what I want to do is I want to add an internal lithium-ion battery. Since I'm using USB power supplies, I want to make it more handy to use with internal battery thing. And the next thing is I want to save battery life. So since I'm using if I want to use battery, means I should definitely care about the battery life. So I need to add a battery monitoring system, as well as I need to make some changes in my firmware to once take a picture, it should go to sleep mode, all these things. So for that thing, I need to rewrite my logical in the code, and I need to test this thing in very rugged environment, because I just tested with my room environment only. So I need to test the same thing with like rough conditions, rough weather conditions. I need to test all these things. So that's all about my project, which is the 3D printed mini time-lapse camera. And if you want to know about my project, just visit this Hackster page and you can easily find out the project. And if you want to more about me, my Hackster profile, this is my Hackster profile, you can just go and check my Hackster profile. And if you want to connect with me, or if you have any questions, please reach out to me on this Twitter or my Gmail. Okay. So thanks everyone, thanks for joining, and have a great day. Bye.
So yeah, that was Pradeep, another maker, and that's what I love about the DIY community, the makers community. So they don't look for the solution; they make the solution for the problem they are facing. That's the beauty of makers like us. We build the solution for ourselves, for community. It doesn't matter, but we build the things. Okay. So that was the amazing project from Pradeep, and now it's the time for another wow technology, which is, I'm definitely sure that you must not have heard about it because it's very new, and you will feel wow. And if you feel wow, just type wow. So let me tell you. So I'm into the Apple ecosystem. See, I'm not promoting Apple all the time, but I love the technology that Apple uses. So I used to wear Apple Watch, and right now the streaming with is an Apple iMac. So what happens is, uh, whenever I am nearby my iMac, okay, when I press any button, it wakes up and it finds, hey, Sachin's watch is nearby. Let's just unlock it without entering the password. So boom, it got unlocked. Okay. So whenever I'm wearing my Apple Watch comes near to the computer, it opens up. This is a simple Bluetooth, what we can say, technology. So it is just checking the Bluetooth, checking the iCloud server, everything. But basically, via Bluetooth, it comes to know that, yeah, this is in the proximity and this is Sachin's watch. So probably Sachin is nearby. Let us unlock it, unlock the computer for him magically. This is not wow. Wow will come right now. This is definitely wow. But what happened is with the advancement of technology, recently Bluetooth or BLE 6.0 was introduced, and BLE 6 has one amazing technology called as Bluetooth channel sounding. Let's take an example. If you use this, can we use this same technology in a car? No, because what happens is, even if I'm on the other room, okay, not so far, but I'm a little far away, and even if someone tries to press any button, it will recognize that, hey, watch is nearby, let's unlock it, boom, it will work. But with the advancement of technology, with the Bluetooth 6, BLE6, a new technology was introduced called as Bluetooth channel sounding, with the help of which now my iMac can know how exactly far the watch is. Is it 10 centimeter? Is it 5 centimeter? Is it 20 centimeter? How far it is? This kind of precision is lacking right now in Bluetooth 5. But with Bluetooth 6 and Bluetooth channel sounding, we will getting a great precision about how far the BLE devices are, and this will open up a lot of opportunities. Means in future, not in near future, in today's time as well, we can easily unlock our car with the help of our phone as well, with the great precision. That's Bluetooth channel sounding. Wow or no? Let me know in the chat section. That is a new technology which I heard about. I thought I found it very interesting. So yeah, that was another wireless technology which I wanted to share with you. And now it's time to introduce another community member with some amazing project. So it's time to call Tom, who made a boat safe and Arduino based boat monitor. Sounds new and fresh. Let's hear from Tom directly.
Hi, my name's Tom Goring, and I'm here today to take part in um, the Impact Spotlight seminar on connectivity. So I'm Tom, and this is my boat. And I'd like to welcome you aboard so I can tell you about a project I've put together called Is My Boat Safe? An Arduino-based boat monitor. Just really quick about me, I'm just an old retired guy. I used to be an engineer. I do a little consulting on the side. I worked for 3.5 decades in water resources issues, both man-made systems and environmental systems. Now I do retired things. I work in my wood shop. I travel. I play with my granddaughter, and I do projects like the one I'm talking about today. Just to give you an idea of what era I'm from, my first computer programming class was in Fortran, and it was based on paper punch cards. It was that long ago. I think it was in 1981. So I created this project called Is My Boat Safe? And well, I've got some bullets here. You're welcome to read them, but I think pictures are better than words. So let me try to explain why I wanted this project. I live in a town called Sacramento. It's California's state capital. Here you can see a map of Central California. If I zoom in to the area around Sacramento, you can see that my boat is kept in a place called, a little town called Walnut Grove, deep in the middle of the Sacramento-San Joaquin Delta, and it's about 30 miles away. And so if I want to know whether my boat is where it's supposed to be, or whether it's still afloat, whether it's sinking, whether it's on fire, I need a monitoring system. I also need a monitoring system because there's some critical information about my boat that just wasn't available to me. In particular, the state of charge of my 2 big house batteries on the boat. Now those batteries are used to start the boat, but they're also used to power accessories on the boat when I'm out on anchor somewhere, hanging out, having a great time. This is a scene from a couple months ago. My wife and I spent three or four nights at a place called Steamboat Slough in the heart of the California Delta. The biggest power load on that battery when I'm out on anchor is my refrigerator. Keeping my beer cold is really important, right? And if I run the refrigerator too long in the batteries, I won't be able to start it and return home. So keeping track of the state of charge is important. The other thing that's important is the amount of fuel I have on board. The boat runs on diesel. Prior to this project, the only way to get an idea of how much fuel I have is to climb down in the bilge of the boat that's under the floor into a space that's about 30 inches tall, and using a sight glass that's installed on the side of the tank, that's that beige thing in the background is the fuel tank, use a measuring tape and let the measuring tape tell you how the height of diesel fuel within the tank. It doesn't tell you anything about gallons, right? So to fix that problem, I installed this thing. It's a stilling well, plumbed into the side of the tank, vented at the top. It's made out of steel pipe. And inside the stilling well is a sensor called a chemical E-tape. Using a reading from that sensor, the calibration curve that I developed, the Arduino converts that reading into gallons. So for the first time, I have a fuel gauge. It's wonderful. Rather than go through sort of a list of the components, let me just really quickly bop through them using this schematic. I'm going to go fast in the interest of time. So I've got current and voltage sensors to keep track of my battery voltage. I've got some non-volatile memory. That is primarily to store the place where I last left the boat. If the system reboots itself, it can find out where it is, but it won't, without this EEPROM, it won't know where it's supposed to be. Next is an environmental sensor. Boaters really like to know what the temperature, humidity, and barometric pressure are. And I keep that in the cabin. So I can find out, is it comfortable in the boat before I even get there? A water presence sensor, that's in the bilge. If the bilge is taking on water, eventually it'll hit the sensor and tell me. The chemical E-tape that I already talked about. Another temperature sensor for the bilge. That tells me in the winter if something is freezing. Other times it tells me if something's on fire, right? If the temperature gets above, an ambient zone. I have a couple of reed switches on the doors. It tells me if someone has entered the boat. I've wired in a couple of relays so I can turn on some circuits if I want to. And then finally I have a GPS unit, which is connected to an external antenna. I would like someday, not added yet, but I'd like to add a push button to control and an OLED to give me a local display. That's because although the IoT just has worked great, sometimes I'm out of cell phone range and then I have no feedback. So it'd be great to be able to have some information locally even without internet connection. I'll list one more component that's not part of the schematic, and that is a mobile hotspot. This thing, the Maker chip, Arduino Maker chip that I'm using is Wi-Fi enabled. It connects to the hotspot that sends me into the internet with cellular. A few notes on design and construction. I built this project as a test bed as part of a competition that Arduino was putting on. And I had a due date in 2 months and I slammed it together and it was great. Didn't win the competition, didn't expect to because I'm a noob. But I kind of did it in record time. It's all I did for 2 months, right? You can do that as a retired person. It then took me almost 1.5 years to install it in the boat, and largely because it required a lot of wiring, running through the bowels of the boat, running wires, installing that stilling well that I showed you. That just took a lot of time. Notable issues about the project. First of all, I was a rank beginner when I started the project. I had never really worked with an Arduino before, had never coded with C. And so this tells me that even an old retired guy can pick up an Arduino pretty quickly. The IDE was pretty intuitive. There are a lot of tutorials out there on how to do this stuff. Another thing I'll note is that I never really got the GPS to work as I would like it to. It doesn't update as often as it should. It's supposed to update every 2 minutes, and it does not. I don't think that's a hardware problem. I think that's a coding problem. I'm just not using the library correctly. Another thing is I have changed out some of the sensors as I began using the project because I found they just weren't compatible with what I was doing. An example was the water sensor in the bilge. I started with a really cheap sort of resistive water sensor. And what I found was that because of the high humidity within the bilge, it gave me false readings. It would say that there was water in there, but it wasn't. It was just basically condensation. So I bought a more expensive digital sensor that is not prone to those false positives. Another note, just from personal perspective, I found that I really love using I2C devices. Their plug-and-play nature, the number of tutorials that are out there. I used a lot of them from a company called Adafruit out of New York. Their tutorials are just wonderful, and it was a joy. And I found that IoT was kind of a nice thing to use. And since this is a connectivity seminar, let me talk about the IoT issues and how well did it work to keep me connected with this boat that's 30 miles away. First of all, I'll say I think it was relatively easy to set up. It has good support for iPhone, so the interface that the platform helped me create, I can look at on my phone. It's been stable, been running for about 2 years. You do, to use the IoT platform, you do have to use their web-based development platform. That has some pros and cons that I won't go into in depth. One of the pros is that it does allow over-the-air wireless updates, coding updates, which again is nice because my project is a ways away. Also note that Arduino keeps adding improvements. They've added a notification function so I could move away from using IFTT, which I found cumbersome. They've added new tools to their suite of widgets, which are little graphical elements that they use to let you build your interface. I don't want this to sound like an endorsement for Arduino. I used Arduino because they invited me into this competition and they gave me a maker board and a subscription to their service. And so I said, let me give it a try. But I'll just note that there are a lot of other IoT platforms out there, and some of them are listed below. Here are a couple of screenshots from my iPhone. This shows battery on the upper part of this screen capture. You can see battery voltage. In the middle, you can see the number of gallons. I think that's temperature in both the cabin and the bilge at the same time, 2 different places. This one shows some of the graphical elements. Graphs are pretty easy to install. That shows voltage of both of my battery banks and how they oscillate up and down as the battery charger does its thing. Below is the level of fuel calculated with the Arduino. You can see a dip in the time series there, and that's probably because the unit probably had a voltage spike and reset, and so for a minute there was a sensor outage. And finally, here's a look at the map widget, which shows the location of the boat. And some of the numbers there show how far I am away from my intended location. Next steps. I'm not actively working on the project. I've got a lot of other things going on, but I do hope to someday fix the GPS issue, someday add an LED display. And I really should update my project page. If you go to it today, what you'll see is the project as it existed the day that I finished the competition. It doesn't show the current status, and I really should update that. I am working on some other projects now. 2 things I'll note is one is that I'm a mentor for the local high school robotics team, and also I'm automating the dust collection system in my woodshop. That's it. I really appreciate your attention. Thanks for this is not an AI project, right? This is not self-aware. This is not doing a lot of the fancy stuff that I see on the spotlights here. But it does use IoT, and it is an example of what someone can accomplish even though they don't have a lot of experience. There's a web address to my project page on the Arduino Project Hub. That's a long thing to type in, but I found that if you just type in 3 words, my last name, Goring, Arduino, and boat, it'll take you to my site. And with that, thanks so much. Thank you to Hacker, and everyone have a great day.
So yeah, that was from Mr. Pradeep, and like Arduino is not just for fun. Arduino can solve some real life problems as well. That this was a beautiful example. And as Mr. Pradeep said, that he don't want to endorse Arduino, but actually Arduino is kind of a thing, kind of a company, which if we don't want to, we ended up endorsing it because Arduino has done a lot of great things. It made the electronics, IoT, embedded systems so easy that a retired person like Mr. Pradeep can make things for himself. And Arduino says open source is love, but I say Arduino is love. And I was lucky enough to hear directly from the founder of Arduino last month during my visit to Europe in Feb 25. It was amazing to hear the complete story from Massimo himself. It was a great moment. So Arduino is definitely love. We should endorse him. Okay. Anyways, so before moving on to the next one, it's time for another wow technology uh, to be shared about the wireless technology that you may feel wow about. But I think if you are following me, if you're following Techie SMS on Instagram and everywhere, which by the way you should follow to stay updated, by the way. But anyways, if you are the follower of Techie SMS, you must be knowing about this. If you're not the follower, well, let me tell you, you'll feel wow about it. So this is something coming from directly Aspressive system. Aspressive is the one who make this kind of amazing boards like the modules, the Wi-Fi and Bluetooth modules, the ESP32 and ESP266. So Aspressive system recently put up a video talking about the new connectivity or technology called as ESP-CSI. You can search for it on YouTube. You'll find the video. What this does is it uses the same Wi-Fi chip, right? But with the help of Wi-Fi transmitter and receiver, it can not only do the wireless data transfer, which a Wi-Fi network does, but it also can sense the movement of a human, and the sensing is so precise that even if I'm in the room and I'm just breathing, it can sensed by this kind of models. How amazing it is. It can sense breathing, it can sense my movements, it can sense if I'm nodding my head, it can sense if I'm standing or sitting, it can sense everything just with the help of this Wi-Fi chip. How cool it is. Isn't this a wow technology? This was put out by Aspressive system called as ESP-CSI. You should definitely check it out on YouTube and everywhere. I talked about it on my Instagram as well. It was a wow technology for me. So with that wow technology, let's move on to the last maker of the Impact Spotlight, and his name is Sridhar, who will be presenting the weather station with indoor and outdoor data. So let's hear from Sridhar now.
Welcome to Impact Spotlights August 2025. Thanks to Hackster for sponsoring this and for inviting me to present my project, which is a weather station that presents indoor and outdoor data, temperature, humidity, and pressure. This is meant as a technology demonstrator. But first of all, let me start with a quick introduction. My name is Sridhar Gopal, and I'm a software engineer turned entrepreneur, maker, and tinkerer. I'm the founder of Upbeat Labs and the creator of ProtoStacks, a modular, extensible, and stackable enclosure system that helps you go easily from a jumble of wires prototype to a functional and attractive one. I love to share my projects on Hackster, and our Hackster ProtoStacks Hub is a primary destination to showcase project idea inspirations that result in fully enclosed prototypes that are functional and more professional looking. This particular project is a technology demonstrator. It showcases a connected weather station with a dashboard. It combines temperature, humidity, and pressure data from an onboard sensor along with outdoor weather data gathered from OpenWeatherMap. Combining indoor and outdoor environmental data allows for many insights around comfort, wellness, thermal efficiency, etc. However, this kind of hardware setup can be used in a lot of other situations as well. Arduino Giga Display coupled with the R1 Wi-Fi offers a neat integrated dashboard solution with plenty of capability and connectivity. The integrated touchscreen offers a dashboard for user feedback and interaction. This is also a functional end solution with an enclosure that makes it robust and neat. It has room for a shield below, a camera above, quarter 20 mounting for tripod wall mounting. This demonstrates capabilities for a full integrated and functional connected smart home solution that can be extended or built upon. The following are the bill of materials that I'll go through in greater detail in talking about design and construction. First, we start with the brains, the Arduino Giga R1 Wi-Fi. It's a dual-core 32-bit microcontroller that allows you to have two brains talking to each other, and each one could be running a separate workload. Wireless communication is through Wi-Fi or Bluetooth with a cryptographic coprocessor for security and RTC for timekeeping. The R1 Wi-Fi has 4 UARTs, 3 I2C ports, 2 SPI, 1 FD-CAN, 2 DACs, and a total of 76 GPIO pins. There are other peripherals such as the USB A and C connectors, a 3.5mm input-output jack that's connected to the DACs, and even a 20-pin RDCAM camera connector. Its companion in ARMS is the Giga Display Shield. It's a seamless touchscreen display for the Giga R1 Wi-Fi. It plugs into the rear of the R1 Wi-Fi, thus giving full access to all GPIO pins. The shield includes a digital microphone, 6-axis IMU, RDCAM connector for a front-facing camera, and RGB LED. For the enclosure, I used the Protostax AG enclosure for Arduino Giga Display, which allows you to easily create professional-looking, seamlessly integrated solutions with the Giga Display and Giga R1 Wi-Fi. Its modular design makes it easy to put together, and there's ample room inside for a shield and for the antenna and for other components. It also comes with an optional camera cutout and an optional 1/4-20 tripod mount that allows you to mount to a tripod or other locations. I used the BME 280 breakout from Adafruit for environmental sensing of temperature, barometric pressure, and humidity. The accuracy of the barometric pressure measurement is good enough to be used as an altimeter with plus or minus 1 meter or better accuracy. The board comes with I2C and SPI interfaces, while I used I2C in my solution. A prototyping shield makes it easier and neater to finish the circuit wiring for a more professional finish. The BME 280 is not directly soldered onto the prototyping shield. Instead, it's connected via a female header cable to the prototyping shield. This allows the sensor to be placed in a better position along the periphery of the enclosure. The prototyping shield also allows you to add more sensors to the shield as desired. For assembly, the Protostack's modular design makes it easy to put everything together. The R1 Wi-Fi comes with an external antenna that you need to plug into the antenna connector on board. You can tape the external antenna to the side of the enclosure if you like. The antenna has a sticky tape on one side, but I just kept it free but positioned it along the periphery for reduced interference. I used double-sided tape to position the BME 280 sensor near the periphery of the enclosure as shown. This allows for better airflow and better ambient environmental sensing while not being affected by the heat of the electronics itself. I used an available Arduino Uno shield that I had lying around, and therefore the GPIO pin selection was based on the available pins for this shield. For the user interface, for the graphical user interface, I used LVGL, which uses a grid display system similar to CSS grid layout. In my case, I had 2 rows and 2 columns. The first row is much smaller than the second, where the main data is presented. The first row shows the location and time. Even though we have 2 columns in the first row, we make the first column span 2, so there's not really a second column. In the main display, we use a combination of images and labels to display the icons and data. I used the LVGL image converter online to convert PNGs of the temperature, humidity, and pressure icons into compatible C files that can be used within LVGL. The default font size in LVGL is not very big, and so I wanted to use a bigger font size. But enabling larger font sizes, while relatively simple, is not straightforward because there are a couple of possible locations where this could be done in source code and you have to do it in the right place. I use the LV timer functionality to periodically run code to fetch new data and update the appropriate labels. I used 2 timers, a timer for indoor data and time that gets run every second, while the timer for outdoor data is run every 60 seconds. Since the outdoor data doesn't change as often, there is no need to poll at a higher frequency and use up your free OWM bandwidth. We also need to connect to Wi-Fi in order to communicate with OWM. And I used JSON to be able to process the results from the OWM API. I also used Arduino secrets to store the Wi-Fi SSID, password, and OWM API key, etc. The OWM temperature data is by default returned in Kelvin, and I have conversion functions to convert to centigrade or Fahrenheit as required. If you'd like to take the project further, you could add more sensors, such as a particulate matter sensor or gas sensors for even more data. OpenWeather Map comes with a wealth of other data that you can retrieve and show. Of course, you will need to update the GUI to accommodate all the extra data while keeping the interface clean. You could use the OWM geocoder API to convert from city, state, location, and country location to latitude and longitude that you can then use when calling weather data APIs. You could make the data units and location selectable by the user. LVGL also provides charts that you can use to show the data over time. You could also interface with actuators or services like IFTTT to take actions based on the indoor and outdoor data, such as turning on a fan, AC, heater, humidifier, etc. To take it even further, the R1 Wi-Fi has a total of 76 GPIO pins for more sensors and even more functionality. And the R1 Wi-Fi is more than capable of running Edge AI with its dual-core support. It also supports Bluetooth and Wi-Fi. The solution has a microphone, 2 DACs, audio jack, FT-CAN, and a camera connector. And this allows for a variety of smart home, auto, and industrial IoT projects that you could tackle. Audio image classification, anomaly detection are some use cases that come to mind. You could also have a federated model in which the device sends data to a cloud service for further integration and processing. Lastly, from a physical perspective, you could mount the dashboard to a wall or tripod. Thank you. You can find the project as well as source code at the links below. And you can check out my Hackster profile for other projects that I've published. Lastly, if you have any questions, please feel free to reach out at any of the social media links below. Thank you.
So yeah, that was our last Impact Spotlight, like maker for Impact Spotlight connectivity, which was Sridhar who presented his Arduino-based project. And with this, we come to the end of the show, right? I hope people who joined the live stream got to know something new from the community people, and also got to know something new from myself as well. I try my best to make this show as much fresh as possible with the fresh tech and technology and everything. Yeah. So before winding up, let me tell you, as I said in the very beginning, Impact Spotlight is kind of a monthly series. So this month the theme was connectivity, hosted by me. Next month we are having the Impact Spotlight, which is having the theme of robotics. So everyone of you watching the stream, if you're interested in robotics, well, you should definitely join. If you're not interested, well, then also you should join. Maybe you can find more interesting project about robotics in the Impact Spotlight, which is happening on September 25th. Okay, so September 25th, Impact Spotlight robotics on this Hackster channel. So I'll hope to see you everyone there. So I'll be also there, but in the audience, not as a host. So yeah, that was all from my side. With this, I'd like to thank everyone who joined the live stream. And yeah, I hope to have a good day and a good night based upon your timestamps. See you.